One, my voice is clear to everyone.
Yes, sir.
So screen is visible to everyone. So today,
Yes, sir.
okay, today I discuss about the current to pressure converter. To current to pressure converter. So current to pressure converter. Actually, what happened in this method? The current to pressure converter works on the flapper nozzle method. Flapper nozzle method. In this method, the input is applied as a current from his equivalent pressure. So first of all, what is flapper nozzle? What is flapper nozzle? Flapper nozzle is a very important signal conversion is from pressure to mechanical, vice versa, and the conversion can be provided by system, and sometimes it is called nozzle system. So actually, flapper nozzle system part of the signal conversion part of instrument, and is a very important signal conversion is pressure to mechanical motion, pressure to also the mechanical motion to special, means that this is the vice versa operation, and this conversion can be provided by a nozzle system which is flapper nozzle system. Okay, nozzle system, this conversion is can be take place. So in current to pressure converter, we actually give the input of a signal as a 4 to 20 milliampere, and we also give a continuous supply of
सर
हाँ बोलो.
सर आपका स्लाइड शो नहीं कर रहा.
एक पीडीएफ शो कर रहे हैं ना जिसपे लिखा
यस
है
सर बट
प्रोडक्ट्स.
यस सर तो रुक गया
ठीक
लगता है
है.
स्क्रीन. आप जो पढ़ा रहे वो नहीं दिख रहा.
ठीक है, हम ये कर रहे हैं, थोड़ा नेटवर्क का इशू है अभी. हम ये करो, हम देखते चेंज चेंज करने की कोशिश कर रहे हैं. ठीक है, तो सुन लो, उसके बाद हम कोशिश कर रहे हैं उसको भी ये करने की. तो फ्लैपर नोजल एक्चुअली क्या होता है, इनपुट में 20 मिली एम्पियर देते हैं एंड विद कंटिन्यूअस सप्लाई, एंड द फ्लैपर नोजल इज कैन गिव द इनपुट करंट सिग्नल इनटू electromagnets that will be activated, and in if there is a current mode, then the power of the magnetic field, अगर current increase करेगा मतलब पोर्ट से ज्यादा होगा, क्योंकि our input range is 4 to 20 milliampere. Okay, and if the current is more, then the power of the magnet will be increased, and the flapper of the flapper nozzle instrument is connected to a pivot, so it can be moved up and down. Pivot as in a jewel bearing pivoted in a jewel bearing. In when I says about the PMC and also moving iron type of instrument, a pivot is with a connected through a flapper nozzle, and pivoted Q because it can be rotate or move freely, and it can be moved up and down, and a magnetic material was attached to other end of the flapper nozzle, and it kept near to the electromagnet, and the magnet is activated. As the magnet is gets activated, the flapper moves from towards the electromagnets, and the nozzle gets close to some extent, so some part of the 20 psi is supplied to the escape. The nozzle of the remaining pressure will be comes to the output, and if the current signal is high, then the power of the magnet will be increased, and then the flapper will be moved closer to the nozzle, so the less pressure will be escaped through the nozzle, and output pressure is increased. अगर करंट ज्यादा होगा, then power of the magnet also भी ज्यादा होगा, then flapper nozzle जो है, flapper it will be, and so less pressure through the nozzle, and output of the pressure is increase. अगर जो होल है वो अगर छोटा हो तो ऑटोमेटिकली इंक्रीज कर जाएगा, क्योंकि अगर छोटा होल से ज्यादा प्रेशर पास करना है तो पॉइंट में मेरा जो प्रेशर जो होगा वो ज्यादा होगा, एंड इन दिस वे द आउटपुट proportional to the input current. For the input current 0 to 20 milliampere, and we can get the output in psi. See, psi. Now my screen is visible to everyone. Hello,
Yes, sir.
Tanya. This is our flapper nozzle. This is our flapper nozzle system. So actually the flapper nozzle क्या होता है? It is the important signal conversion is from pressure to mechanical motion. Pressure to mechanical motion. Here our supply pressure is restricted, and this is our nozzle, and this is the gap, and this is pivoted to the flapper, and this is our flapper motion, and this can be freely moved up and freely moved up and down. This is up, this is up, and this is down, and this is our signal pressure. This is our signal pressure. And in this diagram, this is pivot and this is flapper, which is freely moved up and down. This is the flapper motion, and this is the gap between the nozzle and the flapper, and this is our supply pressure is restricted, and this is our output signal pressure, which is to be convert from current to pressure, which is current conversion from current to pressure. And most of the signal conversion is from pressure to mechanical motion, and also mechanical motion to pressure is vice versa. So in this figure, what happened, this conversion can be provided by the flapper or the nozzle system, and a diagram of this device is shown in figure below. And a regulated supply of pressure, usually 20 psig, and provided to the source of air through the restriction path, and the nozzle is open at the end where the gap is exist. Means that, just 1 second. This is supply our pressure, which is 20 psi through the restriction path, and this is our nozzle, and this is our gap, and this is the small hole which pass the pressure through this nozzle. And nozzle, if this nozzle is present, so pressure will be passes low when the supply pressure is low. So as a regulated supply of pressure, the usually 20 psig provide a source of air through the restriction, and the nozzle is open at the end where the gap exists between the nozzle and flapper. वो जो स्ट्रेट लाइन की तरह है वो मेरा फ्लैपर है, और जो इस तरह जो है वो मेरा nozzle है. And the air gap escape the region, in this region if the flapper moves down and it's close the nozzle. अगर नीचे आएगा तो क्या होगा, मेरा जो नोजल का मुंह, मतलब ये है नोजल का, नोजल जो ओपन है उसको क्लोज कर देगा. एंड इफ द प्रेशर इज अप टू द अपर डायरेक्शन, दिस कैन बी नोजल इज ओपन. So if the nozzle is open at the end where the gap exists between the nozzle and flapper, and the air escapes in this region, if the flapper moves nozzle opening, no air is leakage in this case, and the signal pressure will be rise to the supply pressure. Means that जब डाउनवर्ड्स में मेरा फ्लैपर रहेगा, मतलब वो क्या करेगा, नोजल का जो मुख है उसको क्लोज कर देगा. ड्यू टू द क्लोज देयर विल बी नो एयर लीकेज थ्रू द नोजल टू द रैपर. एंड देन द और अप्लाइड जो सिग्नल प्रेशर, अप्लाइड जो प्रेशर है, जो सप्लाई प्रेशर है, इट कैन बी rise to the, it can be seen outside the our output, which is signal pressure. So opening, so that as a flapper close of the nozzle and as a flapper moves away, the signal pressure will drop because of leakage of air. अगर upward में जाएगा तब क्या होगा, nozzle मेरा leakage होगा. Due to the leaking there will be air is passed through the nozzle to air or the flapper, and finally when the flapper is far away, the pressure will subtract at the some value determined by the maximum leak through the nozzle. मतलब जो flapper है जब maximum एवरेज चले जाएगा मेरा नोजल से, तब क्या होगा, जो लीकेज जो प्रेशर है वो मैक्सिमम होगा. ओके, सो दिस इज आवर ग्राफ बिटवीन सप्लाई प्रेशर एंड सिग्नल प्रेशर, एंड दिस इज द गैप डिस्टेंस, एंड सिग्नल प्रेशर वर्सेस गैप डिस्टेंस, एंड दिस इज आवर सिग्नल प्रेशर एंड दिस इज आवर गैप ऑफ distance. So if the gap is increased, so pressure is decreased. If the gap is low, then supply pressure is high, or the signal pressure is also high. And it shows the relationship between the signal pressure and gap distance. Note that the great sensitivity in the central region, and a nozzle or flapper is designed to operate in the central region where the slope of the line is greatest. In this region, the response will be such that a very small motion of the flapper can be changed the pressure by ordering the magnitude. And this is our current to pressure converter flapper nozzle type instrument. And this is the how to working principle and calibration procedure of I to P converter. This is the diagram is same, and this is some connected through a spring, and it is our current which is 4 to 20 milliampere supply, and all the diagram is same as to be same, and our signal pressure is 3 to 15 pressure, and applied signal or applied current is 4 to 20 milliampere, and the supply pressure is 20 psi. Supply pressure is 20 psi, and our main motto is that to convert the current into signal pressure. So this is our block diagram. This is the diagram of current to pressure converter. So how this can be worked? The current following through the operating coil means that flapper coil, or this coil, and which is attached to the flapper. So current flowing through the operating coil is energized all I to P converter. They can be operated from a voltage supply from which corresponding current will be drawn in ohms, or the V equals to IR, and a unit is calibrated from current source to and are current to pneumatic, and I to P, and the voltage source is E/P, means voltage to pneumatic. And if these are do not differ essentially from each other except in minor manufacturing. If the current to pressure converter is a very important in process control, current to voltage pressure converter is a very important element in control. When we want to use the low level of electric current signal to do the work, much easier let work will be done with a pneumatic signal, and the IP converter gives a linear way to translating the 4 to 20 milliampere current into 3 to 15 psi signal. And there are many designs for this converter, but the basic principle almost always involves the use of flapper nozzle method or flapper nozzle system, which is shows the figure of above, and the current below, and the current through the coil produce a force current through the coil which produce a force that will tend to pull the flapper nozzle down, and the close of the gap and the higher current produce a higher pressure, so that the device is direct acting and adjustment of spring and perhaps the portion relative to the pivot which are attached to the unit to calibrate, so that the 4 to milliampere corresponding to 33 psi and 20 milliampere is corresponding to 15 psi. And current to pneumatic converter are two-wire precision instrument which is designed to convert the standard industrial electrical input signal into the proportional pneumatic output signal. And they are force balance instrument which force balance instrument using a coil suspended in a magnetic field of operation of the flapper valve against the air nozzle to create a back pressure on the control diaphragm of a booster relay, and they compact with the robust instrument suitable for panel measurement. And the input signal for this measurement is that 4 to 20 milliampere, and it is DC, and output is 3 to 15 psi. If the input current is 4, then output signal is 3, and if the input current is 6 and output current is 4, yeah, if the output input current is 8, then the output pressure signal or output signal is 6, and our supply pressure is 20 psig. सो एक्चुअली क्या होता है, जब एक करंट को एनर्जाइज करते हैं तो ड्यू टू दिस एनर्जाइजेशन करंट द फ्लैपर इज मूव्स डाउनवर्ड्स डायरेक्शन, सो ये नोजल जो है ये मेरा क्लोज हो जाता है, डाउनवर्ड्स अगर क्लोज हो जाएगा तो एयर passes through this knowledge is be very low or almost close. So we get the now the relationship is the relation between the current and pressure is here linearly. If the current is increased, so pressure also increase. A current to pressure converter. And this is observation of is if the input current is 4, then standard output pressure is 3, 12 then 9, 16 then 12, and 20 then 15, 20 then 15. And linearity of the IP converter is percent of output span between 3 to 15 psi. Now next one is that pressure to P to I converter. P to I converter. Just opposite means input pressure is 3 to 15 psi and output current is 4 to 20 milliampere. Just 1 second. This diagram is too much complicated. So this is another observation which will be convert the input is the here is the pressure and output is standard output is the current. If the value of input pressure is 3, then output current will show the 4. And if any question is that thing is in that if why the range is 4 to 20 milliampere, so 4 actually is the value is here the live zero. If some instrument has zero input but output shows the zero, but we cannot understood that where the input is given or not. So the for this reason, so the ammeter reading or the mic is current reading is 4 is called here live zero. Value is live zero. If the zero input and output is zero, then this is the dead zero or dead zone. And if the zero input shows the 4 in milliampere meter, then it is the live zero.